Hello class, and a warm welcome to our online learning session. For today's class, we're going to start over with the risk and return module. Now, as earlier indicated, having a good understanding of risk and return will aid the financial manager in making the appropriate decisions for their firm. So let's continue. Now, under this module, we're going to try to get some concepts and skills. Specifically, we want to know how to calculate the return on an investment, how to calculate the standard deviation of an investment's return, understand historical returns and risk on various types of investments, understand the importance of normal distribution, and understand the difference between arithmetic and geometric means. And then we're going to also add up with the concept of capital asset pricing model. So that will be captured in the outline. So we'll look at the return statistics, the risk statistics, portfolio theory and diversification, and then the capital asset pricing model. So for starters, take a case that you have invested in stocks. Now your initial investment is the amount that you used in the purchase of the stock, and then after investing for a period, let's say 1 year, at the end of it, you would have the price for which you can sell off the stocks and hopefully dividends you may have received from holding on to the stock. So in total, your monetary returns will be the difference between your initial investment and the market value plus the dividend that you have also received. Now that in total tells you the returns that you have made in terms of monetary returns. Now when it comes to the percentage returns, you scale that by your initial investment. That tells you how much you have returned in terms of your initial investment. So now let's take an example. So for a typical monetary return where we capture the dollar return, we have the dividend and then the difference in the market value. So that's the change, the closing value less the beginning value. And so when you divide it by your beginning market value, which is your initial investment, you have the percentage return. Now, that dividend divided by your initial investment tells you your dividend yield, and then the change you may have experienced in the market value now tells you your capital gains yield when you divide it by the market value. Now, it may turn out that over the period of, let's say, 4 years, you've held on to a particular investment, and during that time you have made some returns per year. Now, if you want to know how much returns you have made for the entire period, then what it just means is that you're going to have the product of the annual returns less the initial investment, so captured as the product of the compounding frame for each of the returns less the one which captures the initial investment. So take an example here. We have an investment that returns 10% in year 1, negative 5% in year 2, 20% in year 3, and 15% in year 4. Your holding period return therefore will be 1 plus the rates of return for each of the years. So once you multiply those, then you take less the 1, and that brings us in this case to a holding period return of 44.21. So for making a return of 10, negative 5, 20, and 15 respectively over 4 years, our overall return is 44.21%. Now, in some cases, you would want to know that on average, how much have you made? When you want to look at the arithmetic average, and that's the arithmetic mean as well, that's quite simple. Just add the various returns over the period and divide by the sample size or the number of years. So in this case, we have 10, negative 5, 20, and 15. Once we divide by the 4, we have an average of 10. Now, using the same example in terms of the return, we realize, however, that there is a negative return in there, for which reason we will have a challenge, because with a negative return, the arithmetic mean has a possibility, the capacity to overestimate the return. So instead, we will try the geometric return or the geometric mean. Now this is similar to the holding period return, except for the fact that after you have taken the product of the respective compounding frames for the period in question, you take the nth root in this case. So if it's a 4-year investment, we are taking the fourth root before we take out the 1, and that tells us that on average, rather, we are not making a 10% like we did for the arithmetic average, but rather a 9.58 as the average rate per year. In order for us to be sure, we may want to compute a 4-year investment using this average return and compare the resulting values between the arithmetic mean of 10% and the geometric mean of 9.58 and see which one truly takes us to the appropriate value at the end of 4 years, looking at 10, -5, 20%, and 15% respectively. So this is what we have. For your holding period return of 44.21, the true average return per year is 9.58. Now let me add that in the event that all the returns are typically positive, the arithmetic mean and the geometric mean will return the same values in terms of average returns. However, where you typically have the negative values in the return frame, then the geometric mean is usually more approximate and just better than the arithmetic mean. So here, this is what we have. For the arithmetic mean, we are looking at the average over multiple periods, and then geometric mean looks at the average compound return per period over multiple periods. Now, all things being equal, the geometric average will be less than the arithmetic average unless the returns are equal, in this case, especially if it does not involve negative returns. Now, which is better? Now, when it comes to arithmetic mean, as we saw from our earlier example, it was quite optimistic, giving us 10%, whereas the geometric average is usually pessimistic over the short horizons, but it turns out, in terms of the geometric average, to be a bit more appropriate, especially where we have negative returns embedded in the list or the portfolio of returns. Now let's look at risk. Risk typically is capturing uncertainty about an investment or any activity for that matter. Now, in general, there is no really universally agreed upon definition of risk. But for the purposes of this class and our finance session, we're going to discuss this particular risk measure in terms of variance and standard deviation. And for the standard deviation in particular, it typically measures the spread around a sample mean, in the sense that how widespread is a collection of returns or values that we are working with. Now, to interpret that, normally we work with the normal distribution frame. Now let's look at an example here where we have a return framework. Now you can look at it from this angle and look at the fact that we have a certain investment, and these are the actual returns that we were hoping to make. Having sorted that out, we realize that we have an average return of 10.5. Then, to get the variance, we take the difference between this 15% less the average, and we have this. Now, once we square that, we have this. We do for each of the periods, and once we sum up, we have 0.0045. Now that we divide by a 4, or in this case, looking at degrees of freedom, we do 4 less 1, and then we have this value. Once we take the square root of that, of the variance, it gives us the standard deviation of what? 0.03873, which is roughly 3.83. Now, having understood the basic details of risk and return, now let's look at some learnings that we can make from this. Now, typically, the characteristics of an individual security that may be of interest to you as the finance manager are the expected return on that particular investment, its variance and standard deviation, which tells you the risk, and then you may also want to know how that co-varies or correlates to another security. Now, this correlation is relevant because it allows you to be able to put together an investment package that suits your peculiar situation. Now, let's try to look at examples here. Now, consider the case where you have two risky investments, and yet for the state of each economy, you have a 1/3 chance or a 33.3% chance of the economy behaving in a certain way. And then the only assets you have are a stock fund and a bond fund. So in terms of scenario, let's say we have a recession, we have the possibility of a normal, and then also the possibility of a boom. Now, each of these has an equal chance, meaning that 33.3% of a chance of happening. Now, should the recession happen, the stock fund will return -%, but the bond fund will return 17%. When the economy, should it happen that the economy is normal, which is 33.3% chance, the stock fund will give us 12%, and the bond fund gives us 7%. And should the economy boom, the stock fund will give us 28%, but the bond fund will return -3%. Now, to be able to therefore look at the average return for each of these, therefore look at the case for, let's say, for the stock, is the 33, which is the 1/3, multiplying the recession plus the same 1/3 multiplying under normal, and then the 1/3 multiplying the 28% should the economy boom. Now, taking an average of all of these occurrences for the stock fund, scaled by the respective probabilities of occurrence for the scenario of a recession, normal, or boom, we end up with an expected return of 11%. Now, with that, we proceed to computing the variance, and that we end up as 0.0205, and then once we take the square root, we have approximately 14.3% in terms of the standard deviation. So this investment has a return, an average return or expected return of 11% and a standard deviation of 14.3%. Applying the same principle of the weighted average, we have the expected return on the bond fund at 7% with a standard deviation of 8.2%. Now, putting all that information together, so this is how we came by it as indicated earlier. So 7 less the average gives us that, and we squared, we have that, and then we proceed, and then we scale accordingly with the probability. So this is what we have as the overall variance, having captured all the respective seasons, and then once we take the square root, this is what we have. So you go through the same procedure for the bond fund, and then we have it. Now, we get to covariance because you want to really understand how any two investments move together. Now, in seeking to understand that, you would know, therefore, how to put them together, because what really then happens is, by knowing how they co-vary, you would want to select investments that together, having captured that covariation, gives you the best return and also minimizes your risk, because as a finance manager you want to make the most return but also minimizing the risk. So having an understanding of the relationship among or between investments is key to making that kind of decision. Okay, so we're going to end on this particular slide for this session, and for the very next session to continue to have a fuller understanding of the covariance and how it relates to investment, we shall go to part 2 of the risk and return lesson. See you on that one.